All right, welcome to our LionSide Chat. We will get started in just a minute here. All right, welcome to Penn State Berks LionSide Chat. Come on in and welcome to our campus. We are very glad that you could join us today. My name is Ryan Hassler. I'm one of 3 LionSide Chat moderators working alongside Don Pfeiffer-Wrights and Sonia De La Cueto. Before we get started, we just wanted to share with you that you should please feel free to submit your questions via the Q&A feature of the webinar here. We will not be utilizing the raise hand feature, but feel free to put the Q&A into your questions into the Q&A chat, and after the presentation we'll be facilitating a conversation. So today's chat is part of a 6-chat summer series on the Penn State values, and the value for the day is discovery. So now we are excited to introduce several of Penn State Berks' finest with regards to discovery. First off, I'm going to introduce all 3 of our presenters, and then we will turn the show over to let them talk about discovery. So first off is Dr. Matt Rudy. He is an associate professor of mechanical engineering at Penn State Berks, and I highlighted in red. So let me just take a point of privilege here to congratulate him on the 2021 Penn State Berks Faculty Research Award winner. He does his research in interdisciplinary topics utilizing sensor technology in various areas, including aerospace, engineering, kinesiology, and psychology. So sounds interesting. He was awarded the research award for the entire Penn State Berks faculty, so we are glad that he is here. I'm also going to introduce you to two Penn State Berks students. First off, Serenah. Serenah Pauliuc is the 2021, hello Serenah, Penn State Berks Young Investigator Award winner from the Engineering, Business, and Computing Division. So again, this is an amazing opportunity to recognize our award winners on campus and hear them shed some light on what they view as the important parts of the Penn State values, specifically today, discovery. And then we also have a recent Penn State graduate, just graduated, Kaitlyn Pasquerella, who I can speak very highly of because she was part of, in my class. I had her for several classes. So she has done amazing things. I can't wait to hear what things she has planned for the future. But she was awarded the 2021 Penn State Berks University Libraries Research Award winner from the Science Division. I thank the 3 of you right off the bat for being here, and I can't wait to have this conversation about discovery and research here at Penn State Berks. So I'm going to turn it over to Dr. Rudy to start the show. Thank you.
All right, so thank you everyone for being here and hearing a bit about discovery. So the theme of my presentation is discovery and what that means in terms of academic research. So the Penn State values, we have integrity, respect, responsibility, discovery, excellence, and community. And as Dr. Hassler mentioned, there's separate LionSide chats on each of these topics. And I'm glad to be here to talk about discovery, which Penn State lists this as: we seek and create new knowledge and understanding and foster creativity and innovation for the benefit of our communities, society, and the environment. Now, what I want to do is to look at this, think about this, what this means, and put that in the context of my experiences and the work that I've done as a researcher in academia, because discovery is something that means a lot of different things. And so I wanted to kind of take this brief statement really and put this into maybe a different context, a different framework, and just put it into different words that relate to the way I think about and look at research from, my role as a faculty member at Penn State Berks. So the first thing I want to highlight here is actually the part at the end, and it's a really important one, that when we talk about the benefit of our community, society, and the environment, that's pretty broad in what that could mean. But the main idea here is, in terms of discovery, we have to have some kind of motivation. So the term I'm going to use here is motivation. And this is something that we use a lot in research as we talk about, well, what's the motivation for this work? What's the purpose? So why are you doing this? What problem are you trying to solve? And so a lot of times this can be coming from somewhere else. This could be coming from a client that is posing a problem, and they do a request for proposals because they want researchers to investigate and try to solve their problem. Or it could be something motivated from your own interests or backgrounds. A lot of times for student-driven research projects, it could be, I'm into this activity, and when I'm performing this activity, there's this problem with it or this issue that could be improved on. And so we need that aspect of motivation to get people invested. So why do we care about this work that you're going to do? Because if there's no benefit, if people don't care about it, if this doesn't lead to some improvement in community, society, environment, etc., it's not really going to lead to discovery. So this is kind of a necessary piece, and it's oftentimes the first piece that you need in order to create new research. The next thing I want to highlight here is really an important one, because a lot of times it's a key component in discovery, but a lot of times it's the most fun aspect of discovery, and that is this idea of creativity. And so in order to really have discovery, a lot of times you need to come up with some creative solution to a problem, because if it wasn't creative, if it was just obvious, it's probably already been done. And so this is where a lot of the art of research comes into play. Even in my work, which is primarily in the field of engineering, there is still a lot of art to research. There is this creative aspect and coming up with things that other people haven't already thought of. And so this can be a really challenging part, but this is where a lot of different people and different ideas can bring really good things to the table using their creativity. So this is an important aspect. The last piece, and this is another important one, in order for us to have discovery, in order for us to have new research, we need to satisfy this idea of novelty, is the word I'm going to use from kind of the research perspective. We use a lot of these terms when we're kind of evaluating research as well. So what's the motivation for this? Is it novel? What's the novelty of this particular work? And that's coming from this idea of new or innovative. These ideas have not already been done. And so that's something that's interesting is, you could approach a problem and come up with a solution, but if you haven't done your research, as in if you haven't looked into what other work has been done by other researchers and other work that's already out there, it's not really going to be a new discovery without being novel. And sometimes this can be a real challenge in the academic research realm, because not only do you need to have this novelty, but you also need to have a way to communicate what this novelty is. So you present your ideas and you have to explain, and here's why this is new. Here's what's different from what these other people have done, which might seem similar at first. So you have to really establish the value of your work. And so in my experience, this novelty one can be a real challenge, because you need to convince others that your work is innovative and new. So I want to kind of bring these ideas together now. So these are all coming directly from that Penn State values statement of discovery. And this is more kind of my my take on how this fits into this context of specifically for academic research. And that's where, I have the most experience in terms of discovery in academic research. And so we need to start by having some motivation. So why are we doing this work? Why is this important? Why do we care? And then a lot of times the work, the main body of the work where you're really putting the time in is exploring this creativity aspect, coming up with your solutions, applying your knowledge in different ways. And that's what's going to bring out the novelty of the work. Your creativity is what you use to create that novelty, come up with new ideas. And that's what's going to lead to discovery. Now, one of the interesting things I want to point out here, I kind of formatted this in a bit of a flow chart, but some researchers work differently, and there's a style element to research. I mentioned this idea that research is kind of an art in how it is put together. I have had work where I actually started with the novelty and then needed to get creative and figure out the motivation for it. Sometimes when it comes to research, you just have an idea and you like your idea and you want to explore it and you want to try things out, and you might come up with something new, something nobody else has done before. But then you kind of need to reflect on that and say, yeah, this is something new. Nobody has done it, but does it matter? Is it relevant? What does this do for society? Why is this something that people might care about? And I have had work, especially when I was a graduate student, with the work that I was doing, I had an idea. I wanted to try something because I wanted to try it. I was interested. I explored that idea. I got creative. But then when it came to leading to that next step, to bring it to a more of a discovery, this idea of this new knowledge, I needed to motivate that work. I needed to convince others that, like, hey, yeah, this is something I did, but here's why it might matter. Here's why it matters to, this particular group. Now, when it comes to discovery, most of my experience and a lot of the kind of thread of this talk is kind of leading towards publications. Typically that is in academic journals in my work, although in some fields like engineering, a lot of conferences will also have a research paper that you would write to accompany a presentation. And so that's where most of my experience is working towards these types of publications. And that's where within that written work, so there's graphics and figures and tables that you can include, but a lot of it is writing. And in that writing, you're going to need to hit all three of these elements, or at least you're going to need to hit the motivation and the novelty. The creativity kind of just manifests naturally as you cover those. That's more part of the process. But you're going to need to cover that motivation and that novelty, because peer reviewers, so people, similar researchers doing similar work, are going to review what you have presented in that written work. They're going to read it and they're going to make comments. And one of the key things that you need to satisfy in order to get published is that, do you have a solid motivation and a clear novelty that is clearly stated in your work? And that can be a real challenge. And that's one of the skills that I've really developed over the years as a researcher. That a lot of research work is in communication, and a lot of times that is in written communication. Although you can definitely present your work, that's pretty common to go to academic conferences or professional conferences and present your work. And this type of discovery, this can also lead to new technology, new ideas. And sometimes researchers will go the road of getting a patent and having patented technology. And so at Penn State, we have our Invent Penn State program that supports that kind of discovery. I don't have much experience in that realm, but that is definitely another path that researchers can take, and just Penn Staters in general can take. We have entrepreneurship and other programs as well with this in mind. So how do we do this, right? So this idea of creating, discovering this new knowledge. So I'm going to highlight one more piece from this statement here, which is my recommendation, my key. So how do I do this? How do I discover? And I think it's right here in this word seek. you have to look for it. You're going to have to look for, if you want to get involved in academic research, you're going to have to look for opportunities. You're going to have to look for undergraduate research grants that might be out there. You're going to have to look for faculty members who might want to work with you on a project. In this, you're going to want to try new things, explore ideas, be creative, think outside the box. You want to read. You want to know about other things that people have done. Read about similar research so that you know how to branch off and lead to your own direction, your own ideas. And keep in mind that with research, it's okay to take risks. It's okay to try things and fail. It's not really a failure, it's a learning experience, and it's all part of the process. Research is not just, I have this one idea and I'm going to do it, and then I'm going to be successful with the first thing that I thought of. Maybe that happens sometimes, but not every time. And part of leading to really valuable new discoveries is taking those risks and trying things that might not work out. There's one more piece to this that's a really important one, and it's another word, just a single word here that really captures a lot, this idea of we. So we, as in research, is very often not done alone. It's often done in groups or in teams. It could be a student working with a faculty advisor. It could be a group of students. It could be faculty working together, graduate students, postdocs. There's a lot of different people that can contribute to discovery. And so another thing to keep in mind is that it's not even necessarily a formal partnership that you have. Sometimes it's just having a conversation, just talking to your friends, talking to your family, talking to people in your classes about what you're working on. They might give you ideas. They might even directly have suggestions that could help you, or it could even just be things that they say, how they respond or interpret your ideas might lead you to new creative solutions. So working with others in many different capacities is another way that can really lead to discovery. So just to kind of give you a sampling of some of the work that I've done, and it very much ties in with that idea of collaboration and working with others. So I have done work with research in kinesiology and psychology. We did a study involving active sitting, so sitting on an exercise ball versus a chair. So that's what these pictures in the top left are showing. So I brought my knowledge of sensor technology and what that looks like in measuring human motion with faculty and students from kinesiology who were more of an expert in knowledge of the human body and the biomechanics of it. And as part of this, we investigated their cognitive aspects. So we used psychology faculty and students to bring in their perspective and psychological tests to see, did people perform better if they were sitting on an exercise ball when doing different tasks on a computer. I've done a lot of research with unmanned aircraft and using sensor data to create new innovative solutions there. One of the main research areas that I got into was dealing with the measurement of wind, the local current wind experienced by an aircraft, which is a surprisingly challenging problem. And this was a research area. I have multiple publications here. It's been a major research area for me. And I just kind of stumbled into it by accident based on a conversation with another researcher in my lab about a problem he was having with something unrelated. And it led to this new discovery. So I know I've already taken more than my allotted time, so I'm gonna stop here. And I believe we're gonna hold questions probably till the end. So I think I'll pass it over now to our next presenter. Thank you.
Yeah, great. Thank you so much. Dr. Rudy Caitlin, if you are ready to go, we'll turn it over to you. So we heard about discovery and the value of discovery and research from a faculty perspective. And now we will hear from two students. So Kaitlyn, are you set to go? Perfect.
Yes, yeah, I am set to go.
Welcome.
Hello, everybody. My name is Kaitlyn. I just recently graduated from Penn State, and I was one of the winners of the undergraduate research award given out by the libraries for my research in chemical education. specifically computational chemistry in the undergraduate laboratory with a focus on acetaminophen. And my research advisor was Dr. Lorena Tribe. So basically, my research focused on, it was very lab-based. What we do is we come up with labs for students to use in our chemistry labs. So this lab in particular was developed by chemistry students in typically their second semester of their first year. So it's called the Peer Developed and Peer Led Laboratory. Dr. Lorena Tribe implements this into her Chem 113 labs, where she gives the students an allotted number of weeks to develop a lab. And then for the rest of the semester, they all run each other's labs to get data and stuff like that from it. So this lab in particular gave a focus for students to learn different various types of lab equipment and get an introduction to different types of chemistry. So even though they were only in their first year, this lab introduced some exposure to analytical chemistry, computational chemistry, as well as organic chemistry. Let's see. So yeah, the focus of this lab was on acetaminophen. One of the reasons why we chose acetaminophen was because it is commonly known as Tylenol, which I'm sure everybody knows what that is. So it was able to give a connection to the students right off the bat from something that they know from their everyday life to chemistry, since they are still so new at it. Another reason is the fact that it is easy to synthesize and a relatively stable compound. So it was very easy for first year students to work with. And then, yes, this is just how we ran through and made the acetaminophen. So students to get exposure to creating or having a reaction go on in the lab. And then this is where I stepped in more, was taking more student data. So this is after the lab was already developed and that class ran through. Dr. Tribe had a second class run through that same lab to gather more data to see if this was actually a viable experiment that they could start including in labs. And we also turned in the research to the Journal of Chemical Education to hopefully get the paper published. So this was just more of data points to help back that up. So yeah, at this point, students do know what this is at the time of taking this lab. They do know how to calculate percent yield. They do know what melting point is. Based on this, the melting point of they were supposed to take the literature value of the melting point of acetaminophen and compare it to their experimental value of the melting point of acetaminophen. And all of them seemed quite on top of each other. So they did seem to fall in acceptable range, but they were slightly lower, which helps to indicate that there was some impurity in the product. And I was a part of help analyzing that. So this is where the introduction to some next chemistries start to come in. This is a glimpse into organic chemistry. So at this point in the career of a first year, second semester student, they have never seen IR spectroscopy before, but this is the introduction into organic chemistry. So they don't need to know specifically what these graphs mean, but what they can do at this point is definitely compare where the peaks are and their heights and everything, because that gives you some more information about the product. So here, as you can see, the one on the top, the one in green is the reference acetaminophen used. So that one, we knew it was acetaminophen when we ran the IR. And then the one on the bottom is the experimental created acetaminophen. And as you can see, the peaks kind of line up to each other. It all looks pretty standard, which helped give the students evidence to say that their product was in some ways pure. Now, another interesting part about my research is the Raman spectroscopy. So here at Penn State Berks, we actually don't have access to Raman spectroscopy. So we actually had to partner with Albright University to help get this part of the experiment done, which is pretty interesting. So it helped expose these students to something that they might not have gotten if they weren't focused in chemistry. So here you can see that the again, students, all they can really do at this point is just compare the peak heights and where they fall on the graph and everything. The top one again is the reference. So that one we know for a fact is acetaminophen. So that's what the Raman spectra looks like for that. The one on the bottom was the experimental acetaminophen. So that's what the Raman spectra looks like for that. As you can see, there's sort of like a weird dip between 2000 and 2500. And we concluded that that was an impurity in the product. And the purple line running across the top is the p-aminophenol, which was one of the reactants used to create the acetaminophen. So we concluded that that might have been some of the impurity in the product that the IR spectra was actually not able to detect. And then, yeah, so this is the last part of new introductions for this lab was an introduction to computational chemistry. Computational chemistry involves making computer models of these molecules. So as you can see in the upper right-hand corner of the presentation, that is the computer model of acetaminophen that was used to make these graphs. So as on the left side of the presentation, the upper left is the experimental. So that is the IR that was from a couple slides ago from the created acetaminophen in the lab. And the IR that is on the bottom of that is the one that was made through the computational chemistry. So we took that computational model and found the IR off of that. And the last part of the experiment was to compare the created acetaminophen to the computational acetaminophen to see how similar their IR spectra was. And as you can see by the R squared value, they were actually very similar, meaning that the product was in some ways pure. And yes, we did the exact same thing with the Raman, where we took the experimental acetaminophen and compared it to the computational acetaminophen, this time in a Raman spectra. And again, by the R squared value, they were very well correlated, and they, yeah, sensing or meaning some purity was in the product. Overall, from this experiment, we determined that the product did contain some impurities, which was not caught by certain types of analysis, but was caught by others, like the melting point and the original Raman spectra did show that there was some impurity. So students were able to see that different types of analyses on a product yield different types of results. So that's why analyzing products through different ways gives you more of an idea of how pure your product is. Another thing is that it provided students with that connection of chemistry to daily life. So like I said in the beginning, since acetaminophen is Tylenol, now they can relate what they just learned in this lab to something that they basically use in somewhat of their everyday lives. And the last most important part of this was they got exposure to many different fields of chemistry, which I know for me as a student was very difficult. I knew I really loved chemistry, but I didn't know what field I exactly wanted to go into. And because we are a smaller school, it's kind of difficult to get exposure to certain types of chemistry, such as such as computational chemistry. So this opened people's minds a little bit more to some other types of chemistry that are out there. And then lastly, I just wanted to share with you one of the posters that I used at one of our conferences. I attended 3 different conferences, the one from the American Chemical Society, the HECBC, and the Undergraduate Research Colloquium, which Penn State Berks hosts. And this is what I presented. Thank you.
Awesome. Thank you so much for the details about your actual research. So for those who are listening, I'm sure she can take questions about her actual research, but I'm also eager to ask questions about the process and how she got involved. So we will get to that. Feel free to submit comments or questions here in the Q&A. But if we can, let's flip over to Serenah. Maybe Serenah, are you ready to shed some light on your research? And then we will facilitate the conversation afterwards. So welcome, Serenah. You're muted still, Serenah.
All right.
Perfect. Welcome.
And you guys can see the PowerPoint?
Yep, it looks good. Thank you.
All right. So I worked, so for me, I am a mechanical engineering student. I'm going into my senior year, and I worked on one project under a few different umbrellas. Primarily, the funding was from MCREU, which was a multi-campus research for undergraduates. And with that program, I was kind of given a advisor from Berks, which was Dr. Amir Barakati. He might be some of your advisors coming in if you're in engineering. And at University Park, I worked with Dr. Charles Bacus. And what I was working with was the effect of moisture on tensile composites with bio-based fibers and matrix. So that sounds really intimidating. It's a really long title, but I can tell you a little bit more in the next few slides. So bio-based composites mean, so a composite in general has two constituents. It's a fabric or a fiber reinforcement and the matrix, which is like a glue. So together you take a fabric, which could be something like a shirt. It doesn't have to be any certain material. You could take a shirt and a few layers of the shirt and you add the glue or the matrix to it, and it hardens and it will make a finalized part. And since the fabric is bendable and the glue is starts as a liquid, you're able to get different shapes like car panels or a flat layer or a body of a bicycle. What makes a composite bio-based is one or two of these constituents, either the matrix or the fiber, derives from plants or a natural resource, primarily plants. I used a matrix that was derived from pine, and the fiber was burlap or jute, if you guys are familiar with it. And the jute fibers are taken from the stem of this plant here and processed and eventually weaved into a fiber. And we ended up, the fiber that we purchased was from Joann Fabric. So it's not anything that's hard to obtain. It's very common. And the industry is starting to adapt these bio-based composites. I think the biggest one is going to be automotive. Here, this image pictured here is a Tesla that has the body panels made out of, it wasn't jute, I believe it was hemp. So it had a reduction in weight, and it was a race car. So that was, less weight, faster the vehicle. A brief background. So the work I am focused on was the effects of moisture on these composite parts. And the reason why is because the composites, the biocomposites, are derived from plants. They commonly still tend to want to absorb moisture even after the composite is made. So there's a lot of failure in these moist and wet environments, which is reducing the different applications of these bio-based composites. So focusing on the degrading in damp or wet conditions, the process that I went through is I made a few biocomposites. I evaluated their tensile properties, which is the properties of the material themselves. And I determined the effects of the moisture on these composites. So I made a few laminates. This one here is specifically a jute or burlap laminate, and I use a vacuum assisted resin transfer molding. So this process, I had 7 layers of burlap, and we layered them on top of an aluminum tool plate or an aluminum flat surface. And we put tape around that provided a seal with a vacuum bagging. And then we turn on a vacuum pump, which is commonly used, like maybe you might have been familiar with air conditioning units and flushing out the air conditioning unit. So we took a vacuum pump, had this sealed part and a cup of resin, and the vacuum pump, once it was turned on, the pressure from the vacuum sucked the resin or the glue from the cup and into the stacked fabric that we had on the tool plate. So far, I've done 3 laminates that we had good results with. The jute and the bioresin laminate is referring to the pine-like glue, and the burlap. The jute petro resin was the burlap and a synthetic made resin, not from any type of plant. And then e-glass, for those of you who aren't familiar, is like a fiberglass. So it's a similar material, like a fabric, but it's synthetic. It's made of like a plastic or petroleum based. And we use the bioresin there, the pine-based resin. So this is our tensile specimen. So I took my flat plate, we cut it up with a diamond saw, and we made these specimens you see in this left image here. And we did tensile testing. So here's this tensile testing rig. This one specifically is at University Park, but we do also have one of these in the lab at Berks. And we use a laser extensometer, and we had tape here. And as these, the tensile testing rig pulled the material apart, the laser was able to read the displacement. And here's an image of how we conditioned in the water. So we took the laminates that were cut up and we put them in, this is just a Tupperware container. In other cases, we use glass jars. And we soaked in deionized water for 24 hours, and we put it into an autoclave or an oven to keep it at a constant temperature. So what we recorded was the weights of our laminates before and after they were exposed to water, and then we calculated the modulus and the strength data. And what we saw was that the e-glass, or the synthetic fiber with the bioresin, had the highest performance in modulus, or stiffness, and in strength. And the jute with the pine-based resin was stronger than the jute with the synthetic resin. And then after the exposure to the water, as you saw, the jute and the synthetic resin was stronger than the jute with the bioresin. So the synthetic resin performed better in the moist conditions. And any questions maybe specifically about my research? And then I think we're doing some Q&A after this, Dr. Hassler.
Yeah, I will. That's great. Thank you. I will entertain questions. It looks like Kaitlyn's having a couple technology issues because she got kicked out, but she's working on getting back in, I think. So hopefully she'll be back to join us. But that was a great introduction from Dr. Rudy. Thank you, about just discovery and what it means from his perspective as a faculty. And then we kind of witnessed here two students who were kind of living out that value through their research and their discovery here as a Penn State Berks student. So let me first ask this question. I think, Dr. Rudy, I liked how you had pulled out those individual words, and the one word that you pulled out was seek. So let's start there. Maybe we'll start with the two students. Welcome back, Kaitlyn. Thank you. We'll start with the two students with the word seek, and then maybe get a faculty's perspective on what you would suggest as well, Dr. Rudy. But how would you suggest, both Kaitlyn and Serenah, for a student who might be interested in doing some undergraduate research, how might they seek out opportunities? How did you get started? How did you get involved with undergraduate research? Let's throw to Serenah first, give Kaitlyn a second. But go ahead, Serenah. How did you get started? How do you suggest to seek out these opportunities?
So I'm gonna say I love Penn State Berks. It's a small school. All my professors know each other. All my engineering, I knew all the engineering professors. So how I originally got started was my professor, Dr. Barricotti, kind of just mentioned it in the beginning of his PowerPoint in class. So it was just a regular lecture. We came in and he was like, I kind of have some research funding. If anyone's interested, meet with me. And I just pursued Dr. Barricotti with that. But I know other years where I haven't worked with Dr. Barricotti, I've pursued, I think I've even walked up to Dr. Rudy before and just been like, hey, are all the research positions filled? Because even if Dr. Rudy doesn't have availability, he knows what his other coworkers are doing. And he might be like, oh, Dr. Nathan is looking for someone and he hasn't had any yet. Why don't you email him? Or any kind of connections like that. I think it's very easy to do at such a small school because of knowing everyone, that even if who you originally approached can't help you, they will likely be able to connect you with someone who can.
If I could do a follow-up real quickly, Kaitlyn, before you answer. You're going into your senior year, Serenah. When did this process start for you in terms of thinking about discovery?
I'm gonna say you can probably get into it in your second year. Freshman year, it might be hard, but if you're able to make a connection early, I kind of had a non-linear path. I started at Berks part-time, so I kind of knew the professors a little bit more than a regular freshman student might. So I think you can get in as early as you can, as long as you're able to make the connections.
Great. Kaitlyn, what was your path? How did you get started?
Actually, pretty much exactly like Serenah's was, where I was just looking for some research. I basically asked my academic advisor, like, hey, do you happen to know if anyone is doing research? Because, you know, they're also in the science division. They gave me a list of science professors who did it, and I contacted all of them. And then, yeah, Dr. Tribe and I just ended up, you know, linking up with research needs and interests and everything. And yeah.
And then
And that also started it was the end of my sophomore year.
Okay, awesome. And then from a faculty perspective, Dr. Rudy, what would tips be or suggestions for students who might see or hear you present on a topic and be interested in what you're doing?
Yeah, and I'll definitely follow up on what Serenah had mentioned, because a lot of that is what I was going to suggest. That a lot of getting started is by having conversations. And those conversations may or may not be who you end up working with, but you want to ask questions. That's one tip. You know, ask about a faculty member's research, show interest, say, hey, you know, what are you working on in your research? Learn more about it. Even if it's not something you're interested in, it's still a worthwhile conversation to have. And then the same thing goes the other direction. Talk about your interest with your faculty members. You know, say, you know, stop by office hours for, you know, one of your instructors, or just stop by, you know, to meet somebody new and say, hey, I wanted to talk to you a bit about this, you know, problem that I'm interested in, or, you know, ask about their research and then mention your interest. Say, oh, you know, I'm really, and it can be anything, be like, oh, I'm interested in, you know, snowboarding or whatever it could be. And through those conversations, like Serenah had said, the faculty at Berks, we know each other pretty well, probably better than at other places. And so you might say snowboarding, and I might think, no, I don't actually happen to know anybody who works with anything like that, but it might trigger something in my head, like, hey, maybe you should talk to this person because they do something similar. So it's definitely the way to start is just by talking to people, and that's going to benefit you as a student, especially, you know, starting out as a first year student. Have these conversations, even if you don't intend on getting involved in research yet. You're still going to learn more about the types of things that are going on, the types of opportunities, what people are doing, and you're going to get to know your faculty. And there's, you know, multiple courses that you're going to have with the same instructors. And as they get to know you, you get to know them. That only benefits your overall college experience. So that's definitely my tip is start having those conversations at any time, and ask questions, show interest. And it can be as simple as our students mentioned. It can be, hey, I want to get involved in research. What are you working on? Is there a way I can get involved? Or it could just be, hey, I'm interested in hearing what kind of work you do. And if after hearing what the faculty member says, you're like, I'm not into that at all, that's totally fine. And that's okay. So have those conversations.
Great advice from all three of you. Again, if you're in the audience, feel free to submit questions. Here's a question I'll you know, add a little bit to it, but the gist of the question coming from an audience member is, is undergraduate research hard? Is it difficult? And let me pull out the word "we" that Dr. Rudy mentioned at the beginning as well. I heard a couple of different people. I think it was Kaitlyn, or you had said you collaborate with Albright because Penn State Berks didn't have it. So there was collaboration with different universities. There's collaboration with different faculties, members, different divisions. Unfortunately, we couldn't secure a student from the Haas division today. I tried, but we have research across all divisions, and you heard the collaboration that we just you know, have had several instances here explained about that. But is it hard? Is there a support system? Kaitlyn, let's go to you. How did you ever view it as a scary type of, you know, thing that you were getting into?
I mean, yeah, I guess in the beginning, it does, before I even started, it seemed a little scary. You know, you think of it as this is so much higher up than what I'm in because you're only an undergraduate student. But once you get into it, it starts clicking, and it actually helps in your classes too. Because I know a lot of the stuff that I was researching really helped me to understand more of my chemistry classes that I was taking down the line too. So I think it's an amazing experience, and it might be difficult at sometimes. You're going to spend a lot of time reading other people's research and everything and putting it together. But in the end, I think it's really worth it, and it'll definitely help you out in the long run.
Serenah, same question. Is it hard? What you did, was it hard?
So I'm going to say initially it is intimidating. You think, I don't know. When I first started, I knew nothing about composites, let alone biocomposites, let alone what matrix even meant. And so I'm going to say it's intimidating, but not to be like the biggest poster child for Penn State Berks, but I had the best advisors that they were perfect in giving me enough structure that I was able to always feel like I was getting something done and keep moving, whether it was just like, hey, we're going to have a meeting to just catch up on what you've been doing. And then just in that meeting, casually in that conversation, we would be able to plan the next step. So just naturally, things were able to fall into place just by having the support from the advisor. And then I would know, like, I would think if I was struggling with something in the lab or struggling with something, even just like writing an abstract, I know I had to reach out because in one case, it was a very tight word count that I needed. And I was like, you know, I've been really struggling on this. I've put in my time. I feel like I can't go any further. And then my advisor was right there to step in and be like, all right, what do you need? Here's some examples. Here's some, you know, abstracts that I've written. And we were able to move forward that way. So I'm going to say it is intimidating, but if you are willing to put in the work, I'm not going to say it's hard. I never had a moment where like I was hitting a brick wall and like in tears and saying, I don't know how to move on. I think there is such good resources and support at Berks that I'm not going to say it's hard, that as long as you are willing to admit that you're struggling and willing to ask for help, you'll be able to succeed.
And of course, Dr. Rudy, with a PhD, research is easy, right? You've been doing research for years.
Yeah, and it's interesting, and everything they said is very accurate with my experiences. And what I'd say is it might feel hard, especially at first, because it's very different than the way you're going to be used to doing things. And it's one of the interesting things when thinking about research, because a lot of the times you might not know how to do something, but that's also kind of the point, because if people already knew how to do it, you might not even need to be doing it in the first place. We're trying to, you know, lead to discovery, things that are new. So it's a challenge. Hard is not a word I would use to describe research, but it can be challenging. But I see that as a positive thing, because in exploring and overcoming those challenges, it's going to be an incredible learning experience, and it can lead to a lot of positive stuff. But the main thing I would say is it's very different, and it's going to be a different way of working with your faculty member too. It's not going to be, oh, you do this and you work on it and submit it, and then I'll evaluate it and give you a grade. It's you're going to work on something, and me as a faculty advisor, I'm going to look at it with you. I'm going to give you feedback. I'm not going to say, hey, you get a B, fix these things. It's going to be, all right, here's some advice I can give you. Here's ways I can improve that. Or if I was doing this, I would do it a bit differently. And you'll find that, and it all depends on your advisor and what kind of relationship you have. But a lot of times it could be like in the example Serenah mentioned, if it's I'm writing this abstract, I'm stuck on this word count, I'm over. It could be send it to the advisor, and we can, you know, help edit that. Because, you know, for me as a faculty member who have done a bunch of those now, that is not a big challenge for me anymore. And that's help I can easily provide to a student. So it's very much a collaboration. You're working together on something, and you're going to be doing new things, which sometimes they might be hard, but research in general shouldn't be thought of as hard, just different, and again in a good way.
Yeah. Let me capitalize on that difference then. So I think several of our audience members are incoming freshmen, right, coming from high school. So couple of years back, Kaitlyn and Serenah, and more for Dr. Rudy and myself, but do you remember maybe what you thought research was in high school, and how has that changed? What's your vision? How has research changed, or what, not research changed, but your view of research or discovery has changed as you've gone through your undergraduate career? Serenah, let's start with you.
Yeah, so I can't say specifically how I might have thought in high school, but I'm going to say I definitely imagine someone with a super level of expertise, someone who has their whole life just studied the same thing and they know everything and they read every single new article and they're just the best ever. And I'm going to say my experience, I feel like I have succeeded well within my own means, and that has kind of taught me almost that anyone can do it. As long as you're willing to actually read the articles and have the uncomfortable conversations, I think anyone can do research. You don't have to be get 2 doctorates. It doesn't have to be anything insane. As long as you're willing to read up on what you need to and put in the work that you need to, anyone can do it.
Has your experience been the same, Kaitlyn, or did you have a different, change in thought about what research was?
No, yeah, I was definitely in the same boat as Serenah in the first place, where I thought, I wasn't far enough into my field to be able to research things. I mean, I'd seen research papers before in classes and stuff, and they were very intimidating. And just looking at them, and I'm like, there's no way I'm going to be able to do this. But then getting into it, and as you start to become an expert in your field, well, almost an expert in your field through the research. And yeah, like Serenah said, you have to put in the time reading all these papers and everything, and actually wanting to move forward. You have to have that drive to continue to move forward. And yeah.
Any comments on that, Dr. Rudy? Do you remember high school? I really don't. So, and I think I remember it being, hey, let's go to the library and open up an encyclopedia. And these students now probably don't even know what that is. But any comments on how your vision of research has changed as you've grown in your profession?
Yeah, I found that, my original take on research and the way I thought of that word back in those days was reading a bunch of stuff, right? And the students kind of hinted at that because that is part of it, but that's only a part of research, because there's the kind of some of the elements I had talked about. That you need that creativity, that motivation, that novelty to build on the things that you're reading about. And absolutely, you're going to need to read things and kind of specialize in a bit of a topic. But that's something where nobody really is going to have that going in. Everybody's starting from somewhere. So even as an undergraduate student, even a first-year student, you might not think you have the background that you need in a particular field like chemistry or engineering to learn about it. And it is a bit of a skill learning how to read journal articles, because they are written very differently than like a textbook. They're heavy and they are hard to read. But once you get started and once you can kind of learn how to read a paper, which a faculty member can really help you to learn and develop that skill a bit, but you're going to find that's what, faculty members with PhDs and have been doing research for years, we're doing the same kind of thing. If we want to be working in a particular area, we need to be reading those papers too and staying up to date. So it's the same thing. It's just, again, it's very different. It's not the way you're used to things being. Because one of the things I wanted to mention is that this idea that with research, we don't already know what the answer is. So this is not like something you'd find in, a math course in high school where the instructor is going to give you a problem and they know the answer. When it comes to research, a faculty member is often going to give you a problem because they don't know the answer and they want you to help them find it. And it's a very different take on things.
Great. All right, I got 2 real quick questions yet to finish out here. This one's just for the students. We've been talking really a lot about research, and you can definitely mention that in your response here. But can you tell me what have you discovered about yourself as a Penn State Berks student? And so however you want to take that question, Kaitlyn, let's throw it to you first. As a Penn State Berks student, what did you discover about yourself?
I mean, actually, I did speak a lot. So I was one of the student marshals at our graduation ceremony, and my speech did focus a lot on how much Penn State Berks has changed me. I found a lot of self-confidence there. The teachers are always very open and welcoming to questions and further comments, and they make their classes very interactive. So I never felt like I was turned down. It always brought me up. And Penn State also helped me to discover what I pretty much want to do with my life. When I came into college, I was going for a biology degree, and as I got through it, I realized, this isn't really what I want to do. I wanted to focus on chemistry rather than biology, and specifically my research actually helped me discover which type of chemistry that I want to focus in more on. So yeah, Penn State, it's very promoting to discovery because they fuel your curiosities. Nobody ever turns you down. They always hype you up.
Awesome. Serenah, what have you discovered about yourself as a Penn State Berks student?
So I think something that improved personally the most for me through research was my communication skills. I was always able to, make the PowerPoints for class and give the PowerPoints up in front of the class, but I mean like nauseating fear of speaking. Like I was able to get it done, but I hated the thought of it. I hated like falling asleep the night before it. Whereas now I learned, I think in gaining some self-confidence, and I know how to make a PowerPoint, and I know this PowerPoint is going to be well put together. I know my material. I know what to say when I don't know my material. That I think my communication skills have really improved the most. And now I'm like, I'm going to give this PowerPoint, and if, I have questions I don't answer, it's going to be fine. Like everything is going to be fine. And I think that's what helped me the most in working with the research was my communication skills and public speaking skills.
Awesome. All right, great. Last question, really short question, and maybe you have just one quick short answer for it for each of you, but what do you hope to yet discover in your lifetime? Dr. Rudy, let's start with you. What do you hope yet to discover?
Good question. Yeah, that's a quick one, right? You make me think.
Yeah.
What do I hope yet to discover? So it's one of the interesting, I'm going to answer by dodging an answer, which is actually a common skill that researchers need to have, especially presenting at conferences. You answer a different question, one that they didn't even ask. What I found that I want to discover is I don't know, because what my research has ended up, like where I'm at in my research right now, I had no idea I was going to be investigating these things even just a few years back. When I came out of graduate school and I was interviewing for positions and things, and I said, this is what I want to do, this is my research path, I didn't do any of that. And the things that I'm working now, I wouldn't have even dreamed of. If you would have told me, oh, this is what you're going to be working on, I was like, I don't know how to do that. And so I've really been able to really discover and explore a lot more than I really could have anticipated. And a lot of that has been through, as I mentioned to the students, is just like the students, I also have conversations with other faculty, and you get ideas, and by working together, you can get involved in some really interesting stuff. For a person with a PhD in aerospace engineering, specializing in unmanned aircraft, to be doing human subject research in psychology, studying the effect of ultraviolet light on things is just, it's a little weird. And I am a little bit weird as a researcher. So I hope that I continue to discover new things that I had not even thought of.
Awesome. I want to be cognizant of time, but real quickly, Serenah, anything that you hope to discover yet?
I think I'm going to kind of tie it into what Dr. Rudy said in his slides. I would hope to kind of tie it into my motivation. I know that even if I don't accomplish great things with what I'm working on, it's really important for me to document everything I'm doing and provide the next student at Berks who might be picking up my research and continuing it. It's that they're going to actually have the knowledge that I kind of worked for. And then, maybe if they don't accomplish great things, maybe the student after that. So I think for me, it's more not what I personally can do, but more like what we can do at Berks to accomplish big things in the future.
Great. Kaitlyn, last words.
Yeah, I mean, it pretty much falls into what the other two said, where I want to help other people out with their discoveries. And within that, I actually end up discovering things myself. Like right now, I'm still working on research with Dr. Tribe, and we're looking at some stuff our past students did, and we're having questions about that now, about certain things that they use in it. So discoveries fuel other discoveries, in my opinion.
Awesome. That is perfect to end. Discoveries fuel other discoveries. So I just wanted to take this opportunity again to congratulate all three of you on your successes, on your awards through research and through discovery. So thank you, Dr. Rudy, Kaitlyn, and Serenah. Wish you the best. Thanks for chatting with us today about our second part of our 6-part series here on the value of discovery. A special thank you to everybody who joined us for today's LionSide Chat. As you do click out of the webinar, you'll receive access to a survey. If you can take a few minutes to fill that out for us, we would love to hear about your feedback from today's chat. So you're encouraged to reach out to us via email and remind you to keep checking our website as we continue to add new chats. Our next chat is scheduled here for actually next Thursday at 1 p.m. And that chat will be focused on responsibility. So the responsibility of a Penn Stater, what does that look like from the Penn State values? So be sure to come back and meet with the faculty, staff, students, learn about our exciting majors and other experiences such as discovery here at Penn State Berks. Stay safe. Berks and beyond. Signing off until next time. This has been the Penn State Berks LionSide Chats. Thank you very much for an amazing chat, folks.